Hello guys, today we will discuss about with the normalization in our SQL series. Uh, so for this video, I will discuss about with the first introduction about with the normalization and one normal form. In part 2, we'll discuss about the second normal form. Part 3, we'll discuss about with the third normal form. Okay. So let's go with the series wise. So if we continue with the in single video, it will be very lengthy. Okay, so first we'll discuss about with the like theoretical. Later, I will move into the SQL server and see with the queries. Okay, so let's see. So first of all, what is the normalization and why we have to use the normalization? So why we have to use the normalization called as mainly it is the process of effectively designing a relational database. Like basically to design a database a very good manner. Okay, so why we have to design a relational database in a good manner called as to avoid the redundancy. So what is redundancy? What is the data redundancy called as mainly? It's a duplication of data. So what do you mean by duplication of data called as? So let's say for example, in a one table, 100 records is there. So 90 records are unique. Okay, but 10 records are in duplicated, but not every column. So those 10 records are not in every column. So those 10 records are 5 records are repeated values. 5 records are the unique. Okay, I mean not in every column. So some those that 10 records. So record means complete row. Okay, so that is why we will see the later example also. This but just I'm giving the one simple example. Okay, so for this, for example, in this scenario, 100 records out of 100 records, 90 records are unique, but 10 records are duplicated, but not every column. So 5 are the repeated values, 5 are the unique values. So do you think redundancy or not? So yes, obviously there is a redundancy, but means 5 are the repeated values. So repeated values, those 5 records are the, uh, I mean redundancy is there. Okay, so we'll look into one example. Okay. So here I had taken as one Excel sheet for to show with the how the redundancy the records. First, I had taken consider with the employee ID. So employee ID is the primary key. So there is no duplication in this column. So based on the employee ID is the primary key. So unique records all the unique records and no there is no null values also. So based on employee ID, we have written as the first name, last name, email ID, okay, gender. So these all employee related information. Then we'll look into the customer information. So customer ID, customer name, customer phone number, customer mail ID, customer address. If you look into this table, some of the rows I have highlighted. Okay, so this row, if you look into these part I have highlighted. So why I have highlighted called as, so if you look into the customer ID 7 has the same customer name. Okay, same customer name, same phone number, same email ID, same address. Because of for this customer is reporting to the employee of this. These are all the different thing. Okay, but employee is relating to these customers. Okay, so this is the duplicated information. So duplicated information means repeated values, redundancy is there. Okay, so this is one simple example of the data redundancy. Okay, let's. So for example, if your table has a primary key, okay, for example, in the primary key called as, let's say assume for this is the table, in this table, employee ID is the primary key. So we can still have the duplicated data. Okay, so your data is efficiently not normalized. So what is the normalization in our concept called as efficiently to design a database to avoid the data redundancy. That is the simple manner of the simple definition of the normalization. Okay, let's now you have the data design properly normalized way. Okay, so like generally we would avoid data redundancy. So this is where normalization comes in. So for example, where we'll look into the normalization and why we have to look into the normalization called as mainly this in turn will to eliminate the some anomalies. So what are the anomalies we have to picture in called as? So some like insertion anomalies, deletion anomalies, update anomalies. So these 3 points I will discuss at the end of normalization concept. Not in this video. The other video I will cover this part. So why these these anomalies uh, will occur the problem. So now the question is, what do you think design a database? So normalization called as mainly effectively design a database to avoid the data redundancy. That is fine. Now, what do you think design a database? So design a database means in order to design a database, you need to understand a normalization first. So that normalization, we have some rules is there. So those rules are mainly like you heard the names generally. So first normal form, second normal form, third normal form, boys code normal form, fourth normal form, fifth normal form. Okay. So this way the normal forms are phased. So these are all the rules. So we had to first apply the first normal form. If first normal form satisfied, then apply the second normal form. If second normal form satisfied, then apply the third normal form. If third normal form satisfied, then apply the BCNF, boys code normal form. If BCNF is satisfied, then apply the fourth normal form. If fourth normal form satisfied, then apply the fifth normal form. So this way, the normal forms are designed. So each and every normal form has some certain rules is there. But basically, in most of the companies or most in different companies or most of the companies, normalization is done only until third normal form. Okay, because of if you expand all the if you apply or if you expand with the data denormalization data is I can apply to the normalization, so it will split into multiple tables. So that is a big problem. If you convert the data into very small parts, that is also one big problem. So most of the companies, the normalization will apply until third normal form. So you can split into the multiple parts or different companies, different requirements there. But so different companies, different requirements called as. For example, you can apply with the this table. For example, this table you can split into 3 or 4 tables. Okay, so that is depends on our requirement. We can split the data. But someone is explain this table. He or she to split the data into 7 or 8 tables also maybe. So that is depends on the requirement, and there is no right or wrong answer. So this is a very it's basically it's a confusion concept of the normalization. So everyone has their own thoughts. Their requirements is to be specific. So you can split into the table into multiple parts in your according to scenario. Okay, so different companies, different requirements. There is no right or wrong. So it just depends on how exactly your company wants to split the data or depending on their requirements. So mainly every record is unique. Okay, so that way we can split the data. Okay, so this is the basic concept about with the normalization. So let's look into some definitions of normalization. So first of all, the basic definition of normalization is, so it is the process of effectively designing a relational database such that it avoids the data redundancy. Okay, so first, what is the data redundancy? So data redundancy can be referred to as data duplication. So even if some of the columns of a table are duplicated for multiple rows, then we can treat them as a redundant data, which can be avoided in a normalized database. Okay. So designing database called as just a process of creating the set of related tables, which will store the data meaningfully as per the requirement. Okay. So meaningfully as per the requirement, we had to split the data. That is called as the normalization, simple way. Let's move into one sample example. So here I have taken as the one example data, that is a denormalized sales order data set. So in this denormalized sales order data set, I have considered as some of the columns in this particular table: order number, quantity, item price, total cost, order date, and status. So this is all the related to the order table related information. But this entire information, this table is to be stored as in one table only. That is called as the denormalized sales order data set. Just I'm explaining how we can consider this data. So this is order related information. And if you look into product code, product name, product price, these all three columns are related to product information, and customer information, and sales information. Okay. So this way the denormalized data is given. Okay. So this is one example I am considering now to apply with the normal forms. Now we'll move into the first normal form, that is called as the 1NF. So for designing the one first normal form, we have certain rules. Now we can follow with these rules. We have only two rules is there in simple form. First rule is every column or attribute. So column or attribute both are same only. So every column or attribute need to have a single value. So for example, we will consider this data set. I will copy this table. Okay. So let's copy this table into first normal form. Okay. So here, first rule is every column or attribute to have a single value. So this table is to be satisfied with the first rule or not. Just check with this one. So every column have a single value only. So every column or attribute. So for example, this is one column. So let's consider as 2, 3, 4, 5. So this is one single value only, 2, 3, 4, 5. Like this. So you can see with this order number. So order number, all the records are single values only. Similarly, you can check with the quantity. So in quantity, we have 4,4 is values there. And item price 780, 850. Next, product code. So two product codes is there. So two product names is there. Product price. So this is the this row is particularly first rule is not satisfied. So we had to split these two records into single value. That is the first rule. So now what we can do is just copy the row and I'm pasting in before. Let's split the record into single value. So first I'll remove with the one value here, and from the next value I will remove here 4, 4. Next here I will remove as the 850, and in this one I will remove as 780. Then this one we can split into accordingly. So quantity multiplies item price as the total cost. So let's multiply this one equal to this one multiplies is 3120. Similarly, this one also 3400. Then order date is fine, status is fine, product code is will remove as the product one product code here, and this one product code as the this one will remove one product code, and buses and product name. So trucks for one product code, buses another product code. Next, okay. Here also product price. Next, 800 and 900. Now customer details. So customer details are auto canal petit. So this one fine, this one fine, this one fine, address, and so remaining all columns are fine. Only order related information and product related information is to be not satisfied. So we have removed that uh, double values, single value. Okay. So first now, if you apply the first rule, every column or attribute need to have a single value. Means this entire table is to be have single value. So first rule is to be satisfied. Then that is fine. Then check with the second rule. Each row should be unique. Each row should be unique, either through a single or multiple columns, not mandatory to have a primary key. So in this one, primary key, foreign key, there is no matter right now in this first normal form. Okay. But each row should be unique. Each row should be unique means every record is unique only. So for example, if you consider as this particular column order number, so here some duplicated rows is there. So this is not a the second rule. Okay, so second rule is each row. So for example, if you check with the one particular record, the record is to be unique. So if you check with all the records, so here how many records is there? Total 7 records is there. So 7 records must be unique. So there is no duplicated data in this part. So if you check with this one part also, for example, in Excel also we'll check with the duplicated records. So apply with the duplicate records. So data, remove duplicates. So if you apply with this part also, okay, so there is no duplicate values found. Okay, so first rule is to be satisfied. So first rule satisfied, second rule satisfied, then first normal form is done. So this is called as the first normal form rules, 2 rules. So every column have single value, each row should be unique. Each row should be unique, unless every record is unique only. That is simple enough. Okay. So this is the first normal form. Just overview summary, what I have discussed here. So I discussed it as first point, normalization. Normalization is mainly effectively to design a relational database to avoid the data redundancy. What is data redundancy called as? So some duplicated values, data redundancy, duplication of data. Okay. Then we discussed about with the denormalized sales data set. So then first normal form. So first normal form has 2 rules. So every column should be a single value. Each row should be unique. That is the first normal form. So in the next video, we'll look into the second normal form. Thank you. Thank you for watching. Please like and subscribe if you like the content.